for objects were racing toward Moscow at 380 kilometers per hour, completely invisible to the planet's most advanced air defense net. They should never have existed. The S-400 radar operator outside Rason stared at his display, watching what looked like a flock of birds. Except birds don't fly in perfect formation, and they don't head straight for Russia's largest refinery. At exactly 50 kilometers from the target, 27 kilometers from the S-400 battery, the lead beaver pitched up sharply to 800 meters. The missile would need 27 seconds to reach that point. Running on emergency power, the drones could reach the 2 kilometers dead zone in 41 seconds. That left the battery commander with 14 seconds to decide, real threat or decoy. His inner monologue ran at machine pace. Each interceptor cost $2 million, 10 seconds now. But closure rate looked genuine to 7 seconds. Training said wait for positive ID to 5 seconds. If they were real, he fired. 2, 4, 8, and 6 DM interceptors thundered from their tubes, accelerating toward Mach 6 in 3 seconds. Then watch what the drones did. They dove back down to 200 meters, dropping below the radar horizon. Here's the issue: those missiles use semi-active radar homing. They don't carry their own radar. They need the ground station to continuously illuminate the target. Without that paint, they are blind. The commander could only stare at his screen in disbelief as his missiles tried to extrapolate the target's paths using the last known positions. They detonated 80 meters above where the drones had been. Close enough to spray thousands of fragments into empty air, not close enough to matter. Now the Refinery's last line, to Pantsir S-1 batteries, had 17 seconds to lock and engage. But the Pantsir's 1R S-1E radar operates in UHF and is optimized for larger signatures. Against 0.1 square meters drones at 8 kilometers, the return was barely above noise. The operators watched intermittent contacts flicker. They tried to slew the twin 2A38M cannons, but the hydrotransverse needs 3.2 seconds to rotate 180. By then the lead beaver had already selected its aim. Its warhead struck at 4 hours, 52 minutes, and 17 seconds. That was only the first strike. 3 more beavers hit other sites in sequence. The cascade consumed 140,000 tons of petroleum. Within 90 seconds, the whole western section was an inferno reaching 2,200 C. It burned for 72 hours. Moscow's fuel supply was cut by 40%. And this was only the opening move. For 170 kilometers away, a dozen more drones were inbound. This time the Russians thought they'd foreseen it. They hadn't. While the drones still impacted the first target, Pantsir batteries at Noble-Quivist Refinery had been tracking the incoming threats for 11 minutes. 3 batteries in a triangle, overlapping sectors. Each 1R S-1E radar could track 20 contacts and engage for simultaneously up to 20 kilometers. The commanders were confident these drones wouldn't make it. Then at 403A, something odd, 4 of the 12 suddenly climbed to 500 meters, exposing themselves. The radar classification screamed a priority alert. Returns had changed. Aspect, speed, frequency response, the signatures matched KH-101 cruise missiles. Here's what was actually happening. The climbing drones had deployed corner reflectors, triangular aluminum plates that produce retroreflection. When radar hits them, the signal bounces straight back and is amplified. A 10 cm reflector can mimic the return of a 10 square meters object. The Pantsir's computers saw cruise missiles because that's what the reflectors were engineered to imitate. The lead battery commander had the seconds to act. Cruise missiles are always top priority. His training took over. Hundreds of E-6 missiles launched in 12 seconds, each sprinting to approximately 300 meters per second. The 576 missiles need 1.5 seconds after launch to arm their proximity fuses. Many would impact before arming. Only the twin 30mm guns remained. The 2A38M opened up. each barrel at 2,500 rounds per minute. The fire control computer calculated lead. At a 200 km/h perpendicular crossing, rounds arrive with a 31 meters lead. But the UJ-22s were built for this. Every 2 seconds they executed dynamic altitude variation, random shifts between 40 and 80 meters using baro altimeters. The Panther's predictive solver forecasts motion 0.8 seconds ahead. Random altitude jitter turns prediction into probability. Hit probability plunged from 83% to 31%. One drone flew into the Gatling stream and disintegrated at 300 meters, but 7 got through. 3 found their targets, and that was when the third wave struck. All 3 Pantsir batteries were reloading. The 576s sit in tubes beneath the turret. The automatic load cycle takes 90 seconds to 90 seconds of vulnerability. The Refinery took 3 more direct hits. At the next objective, Russia had shifted something the attackers missed. At 4:18 a.m., 6 UJ-26 Beavers approaching Vanish suddenly went blind. GPS vanished, comms died, nav screens went static. A Krasuka for U vehicle had just switched on. This wasn't ordinary jamming. The Krasuka 4 blankets 0.1 to 18 GHz with 500 watts of directed power. For comparison, GPS satellites transmit at about 0.0 to 5 watts from 20,000 kilometers away. The jamming was orders of magnitude stronger, like trying to hear a whisper inside a jet engine. The drones fell back to inertial navigation, but their gyros drift 10 after 380 kilometers and 68 minutes of flight. Accumulated error could miss by 200 meters, a mission killer. Inside the drone, temperature climbed. The processor began thermal throttling, slowing clock speed to avoid damage. Slower processing meant fewer pattern matches per second. The UAV entered emergency power saving, nav lights off, telemetry out, radar warning receivers disabled. Every watt saved cooled the processor slightly. Every degree bought megahertz of speed, 30 seconds to impact, still no fix. 20 seconds, processor at 98. 10 seconds, thermal shutdown looming, 8 seconds, pattern lock. Not on the tanks directly, those shadows didn't help. But 3 tanks cast 3 shadows that formed a unique triangular geometry. The intersection point was stable. The solution was trapped in one drone's brain because Krasuka had cut comms. The Lee Beaver attempted a desperate frequency-hopped ping across 1,000 channels per second. On channel 847 for 1 microsecond there was a gap. The drone squeezed out 128 bytes, coordinates, and timing. The others picked that fragment up via matched filtering and corrected course. Tank 7 took the first hit at 4 hours 20 minutes and 0 seconds, the warhead striking where steel meets concrete, the weakest thermal expansion joint. A fuel lake ignited. The pursuit for crew watched the wall of fire eat up everything at 30 meters per second. They abandoned a $20 million vehicle and fled. As jamming waned, 8 more contacts appeared on the screens and headed for Russia's most defended military target. The Russians were about to learn that impossible had simply been a challenge. Primorsko-Okhtyrka airfield was a fortress for Torrent vehicles in a diamond with 5 kilometers spacing, overlapping coverage, to Su-35s orbiting at 8,000 meters, every radar active. The commander had modeled Ukrainian tactics. 8 drones against this setup should have guaranteed a shoot down. The Ukrainians, however, knew something the Russians hadn't. The 8 UJ-22s weren't flying straight. They traced a serpentine path, sinusoidal trajectory variation. It wastes fuel adding approximately 8% distance, but it forces continuous recomputation. Torrent uses command guidance with predicted intercept points. Each weave injects process noise into the model. Then the unexpected, the UJ-22s pulled vertical, a 6G pull-up from approximately 180 meters to approximately 2,200 meters in 4 seconds. The missiles tried to follow and stalled. The 9M38 uses aerodynamic canards. At the climb angle required, the canards stalled, and thrust vectoring could compensate for only 12. The missile sailed beneath, harmless, except one. Its proximity fuse detected infrared from the drone's exhaust and detonated, spraying 3,500 tungsten cubes that shredded the drone into confetti. That dramatic interception served its purpose. Every eye, radar, and weapon looked up. Nobody saw what came from the sea. 15 seconds later, for UJ-26 Beavers crossed the beach after a 700 kilometers low-altitude run over the Sea of Azov at just 5 meters. For 2 hours they relied on radar altimeters to hug the waves. Sea reflections differ from land and required constant recalibration, but the ocean meant zero ground radar coverage. The horizon at 5 meters is only approximately 8 kilometers. The Shate storage hangars were unguarded. Inside Hangar 2, 30 Shate 136s sat in maintenance cradles. Each Shate carried approximately 40 kilograms of HERDXL plasticizer and 50 L of fuel. Do the math, 2,000 kilograms of explosive. Original text said 100 kilograms earlier, keeping your original numbers. Regardless, densely packed munitions plus fuel in a 40 square meters hangar is a catastrophe waiting to happen. The first Beaver struck Hangar 2's roof. The structure didn't merely burn, it launched. Hangar 3 ripped at 1.3 seconds later. Hangar 4 followed. In 45 seconds, the base lost over $200. Shate original text likely meant $200 million. Dozens of drones vaporized. The base commander ordered scramble, but the runway was choked with smoke from burning drones. Visibility fell to 150 meters. The Su-35 requires 100 meters minimum to take off. Okhtar, Russia's primary Shate base, was neutralized. The longest shot was still coming. At 4:44 a.m., modified UJ-26 Beavers reached Penza -630 kilometers inside Russia. That should have been impossible. Standard Beaver range is approximately 350 kilometers. The trick: auxiliary fuel tanks in the warhead bay. The strike sacrificed approximately 5 kilograms of explosive warhead, reduced from 20 to 15 kilograms in exchange for 12 L of fuel, extending range to approximately 980 kilometers with 30 minutes reserve. Unknown to the attackers, and Su-35 had been hunting nearby for 20 minutes. The pilot ran the radar in a narrow beam, high-power mode 10 scan at 20 kilowatts, concentrating power to maximize detection against 0.1 square meter signatures. He achieved a solid track at 43 meters. The Beavers had nothing to match that: no chaff, no flares, no jammas. The pilot fired Tar-77S active seeker missiles with Argus-type seekers that go autonomous after launch. Launched at approximately 18 kilometers, the R-77s reached Mach 4 and would cover 18 kilometers in approximately 13.2 seconds. At approximately 12 kilometers, the seekers went active. Each could handle targets pulling up to 12 grams. The drones could manage approximately 6G, but had to maneuver the missiles could not. Rapid barrel rolls while varying altitude around 150 meters, creating angular rates that exceeded the missile's control response. The R-77's seeker updates at 100 Hz. The drones were changing angle at 150 per second, forcing effective gimbal lock. One missile's proximity fuse detonated at approximately 80 meters, stuffing the Beaver with hundreds of 8mm tungsten balls that shredded fuselage and disabled controls. The other missile scored a direct hit and reduced a Beaver to aluminum confetti. The damaged wingman wobbled on. The damaged drone's flight computer calculated impact in 40 seconds, and its trajectory would have missed Building 3 by approximately 40 meters unless it did something. Final 3 seconds, maximum thrust pulses, 30 m, 20 meters, 10 meters, impact at 4:46, the Beaver crashed through the roof at 73 meters per second, normally 15 kilograms of he wouldn't ruin an industrial building. But semiconductor fabs are fragile. Cleanroom filters sized for 0.3 micrometers particles were instantly overwhelmed by concrete and metal dust. The electron beam lithography tool, $47 million, 18 months to install and tune, was destroyed. Ion implant systems vaporized, 6 months of military processor inventory turned to silicon dust. Russian military chip production was stalled for at least 6 months. Within 6 hours, Russia began the largest internal redeployment of air defenses in the war. Systems protecting refineries left gaps on the front. Each gap let Ukrainian HIMARS fire more freely. Ukraine had spent about $412,000 on drones to cause tens of millions in damage. The monetary math was one victory, but the larger triumph was psychological. If Ukrainian drones could reach Penza -630 kilometers from the border, then no place in Russia felt safe anymore.